try to push the book in that direction, say F2. Somebody has their mic on. Please mute your mics as you join so that we may not be getting a feedback. Thank you. Okay. So say you push a book with this force F1 in that direction. Whatever you do, if the net force, what we mean by net force is actually the sum of all these forces acting on this book that are external. We're not considering the forces of those atomic particles, the forces between those atomic particles, no, but externally applied forces. So the externally applied forces would be F2 and F1. So F2, if you push the book downwards and the table is just, let's say, on some solid ground, says that is some solid ground, and this table is just firmly made, this force would cause no motion because the book is actually standing on this firm flat surface of the table, and the normal force with whatever force you are using here, as long as this table is going to withstand the force F2, the book will never move. But if this table cannot stand that force F2, this table just break, causing the book to fall. But this external force F1 would cause the book to move if it was large enough to overcome its mass. Are we together? Yes, we are together. Then here I just jotted down what net force is actually is. It's the vector sum of all external forces. Vector sum, we might need to resolve the x-axis, the y-axis. That is what we are actually talking about when we get to this point. Then here I just defined mass and inertia. One of those multiple choice questions you'll get in physics. So mass is a measure of the object's resistance to change in its motion due to a force. So what do we mean by resistance to change? Say you have a truck weighing 15,000 kgs. If you apply a force of 7 newtons, nothing will happen because the mass is actually greater to resist that force of whatever value I just gave. That was, I think, 7. Then inertia is the tendency of an object to continue in its motion, in its original state of motion. Say you throw a ball at someone. The inertia with which the ball has and the force that someone would need to apply to stop that ball from moving would actually need to be greater than the mass. Am I making sense to anyone? Okay, look at that as a yes. The Newton's second law of motion states that the rate of change of momentum of a body over time is directly proportional to the force applied and occurs in the same direction as the applied force. Or in other words, that the force on a motion is directly proportional to its what? I intentionally use the change in momentum so that maybe we can have a little feel of what momentum and force have in common, so that at least it may give us quite a show so that we may understand fully. Just try to scribble something for you so that you may see. Just open my book here. You people are not responding. Am I just speaking alone or you guys are getting what I'm saying?
They're getting it.
Okay, online learning, you might need to respond a few more times because I might just lose you guys to connection.
All right, you will.
Okay, thank you. So this second law of motion, we can also state it that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to the mass, which is actually this statement here. But let me just work out this. I'm saying that force is equals to the change in momentum. P is momentum with respect to what? Time. Change in momentum with respect to time. What do we know about momentum? We know that momentum P, momentum is equals to mass times what? Velocity. Mass times velocity. So if we were to replace this there, so we would have force is actually equals to the change in momentum, which is mv with respect to time. M is the mass and V is the velocity. Since M is the mass, mass does not change with respect to anything unless you just cut off something from it, changing its mass. So we can actually factor out this mass because velocity and time, these guys are related. So in this case, we would have M, change in velocity with respect to what? Time. And we know that whenever we are dealing with change in velocity with respect to time, what we're actually talking about is what? Acceleration. Acceleration is from those equations of motion. Acceleration A is equals to say V final minus V initial, which is VO, divided by the change in time. So this can also be expressed as just that. This is the same as saying dv dt. So we can actually replace this with acceleration, which will just give us ma, which leads us back to this guy here. That was that definition. So here I was just trying to derive a force, this formula for the statement for Newton's second law of motion using momentum. Then for the units, you may have units as newtons per kg for acceleration, or you may just define those. This is actually for a force. This was a typing error. This is actually a force. This represents a newton and not the units for acceleration. These only are the ones that are the units for acceleration, meters per second squared. Meters per second second. Okay, I think that wraps up my introduction. So let me try to share the tutorial sheet. Then we can try to solve one or two questions from there. But it would be very helpful if we were to point out challenging questions from the tutorial sheet, if at all you tried it, so that you may just go straight to the questions of concern. Okay. Can somebody confirm that this is a tutorial sheet 3 for physics 1010? Hello.
Yes, I did.
Okay, thank you very much. So your response. So I'm going to tackle question 1 first, or is it anyone's concern that we check out any other question? Okay, my concern transcends them all. Okay, question 1 says, A 45 kg woman stands on a spring scale inside an elevator. The scale reading the force with which it pushes upwards on the woman. What does the scale read when the elevator is accelerating upward at 3.65 meters per second squared, and B, downwards at the same, excuse me, at the same acceleration? So let me just try to share the whiteboard and ignore this part. I'll read the question again. But let me just share the whiteboard. Okay, so let us try to get data from this question. So it says the spring scale measures the scale reads the force with which it pushes upward on the woman. So it says a 45 kg woman. Let's jot down what mass it is. What mass is, say M. So let me say question 1. So M is equals to 45 kg. Excuse me. M is equals to 45 kg. Then let's take gravity G as 9 point, let's just say 8 newtons per kg. If you want, you can say meters per second squared. It doesn't matter. We're talking about the same thing. So I'm going to represent a woman by a dot. This is what we call a free body diagram. Free body diagram, FBD, free body diagram. So what we can actually deduce from this question is that this scale, since they've told us that the scale reads the force with which it pushes upward on the woman. So the woman is standing on this scale. I would have drawn a woman standing on a scale, but the drawing would just be so pathetic that you guys will be bored. So instead, let's represent a woman by this dot. So the measure of the scale is the force would be going in that direction. The scale pushes the woman upward. So let's consider this as the normal force, which is N. Then the weight of a woman is whatever is being pushed what? Downwards. So say this is the weight of a woman. Let's call it W. Then A. So A, they are telling us that the elevator is accelerating upwards at the velocity, at an acceleration of 3.65 meters per second squared. So let's say A is going to be 3.65 meters per second squared. Please pardon my handwriting. So in this case, we might need to consider our axis nicely. So the first thing we need to do is, say we go back to those notes I was sharing. The first law of motion says, an object at rest or in uniform motion will continue in its state until compelled to change by a net external force. So a net external force, the net force is actually the vector sum of all external forces. So in this case, we're going to take the vector sum of all these external forces. And in this case, we only have two external forces because this woman is in an elevator, which is actually either moving up or down. So I have 10 minutes remaining on this meeting. In case the meeting ends, it cuts us off. Just join using the same link. Hope we'll cover a few questions in 40 minutes. So we sum up these forces. So let's take upward as positive. Then downwards would be negative. So the sum of these forces, this is actually a statement of Newton's second law. Is actually going to be, since upward is positive, so we are going to consider this force moving up here as what? As it's positive n. So this is n. Then this force going downward is going to be negative. So it will be minus W. What is W? W is actually the weight of a woman. So we are just actually trying to find what this N is. N is actually what is recorded on the scale. So F would actually be equals to N. We don't know what N is, minus what is this force? What is this force W? It's just this times that, right? Are we together? 9.8 times 45. What is 9.8 times 45? I'm sorry, I'm just going to write it out instead of writing those individual values due to time. So I hope you guys have your calculators. Can somebody multiply 9.8 times 45 and confirm that it gives you 441 newtons, since it's a force. It's going to be 441 Newton. This is actually the sum of all these forces that are acting on this woman, where N is actually what is the reading on the scale. Then what do we know about these forces? The second law of motion, not law of motion, yes, the second law of motion says F is equals to acceleration times the mass. And this F, it has to be the total sum, the vector sum of all the external forces, which is actually this. So we're going to equate these two equations. We'll have AM is equals to N minus 441. I may ignore the units for now. We know that this is in newtons. Then this acceleration A is actually this guy here. And the M is actually this 45. So if we are to replace these guys, we have 3.65 times 45 is equals to N minus 441. So if we were to multiply this and take this 441 to the other side, what we'd actually get is N is equals to 441 plus whatever value you get after multiplying those two guys there, which is 164.25. Hope someone with a calculator confirms that this is actually the value they get as well. 0.25. The sum of the two gives us 605.25. Since it's a force, it's going to be measured in newtons. So this is what actually the scale would be reading if the elevator was accelerating upwards with this acceleration. Then what happens if the elevator is accelerating downwards with this same value of acceleration. Let me just move on to the next board. I hope I'll finish this in the next 5 minutes. So using the same free body diagram, we say that at this point, this is N, the normal force. Then this is W, which is the weight of the woman. The sum of all forces is equals to N minus W. N is what? The normal force, which is the reading on the scale. M is what? Again, it's going to be the same value, which is 441 newtons. But then the summation of all forces, this summation of all forces is equals to M times acceleration, which is also equals to these two guys, which is N minus 441. Remember, we took moving in the previous board, we said, let moving up be what? Positive, and moving down be what? Negative. So since this elevator is now accelerating downwards, the acceleration is going to be what? Negative. We're going to consider it negative. So M is going to be negative. This guy A is going to be negative 3.65 times 45 kgs, which is going to give us the sum of all the external forces. Therefore, our N would be equals to 441 minus, what is that value? This value is going to be 164. It's 164 there, 0.25. Therefore, our N, which is the reading on the scale, would be 041 minus 164.25. 276.75. 276.75. This is a force, it has to be in newtons. So this is what actually would be the reading if the elevator was accelerating downwards with that magnitude of a force. Oh, not really that magnitude of the force, but that magnitude of the acceleration. Are there any questions? We have just 1 minute. The meeting is ending, so I'll solve the next questions in our next meeting. But for now, do we have any questions about this?
Yes.
Okay, please go ahead, sir.
Yes. What does the N represent in that formula?
The N represents the normal force with which the scale exerts on a woman. If you remember from the question I read in tutorial sheet 3, it was saying that a 45 kg woman stands on a spring scale inside an elevator. The scale reads the force with which it pushes upwards on the woman. So N represents that force which is pushing the woman upwards, the reading on the scale. Is that okay?
Yes. So, what's the difference between the tension?
What's the difference between the what? The difference between the what?
The tension force
And the normal force. The tensional force, a tensional force is a force that exists within a cable or a cord, so to say. But in this case, this woman is just standing in an elevator. Less than 1 minute before this time ends. Say this is an elevator. So we have this woman. This woman indeed. Let's assume she's standing on both legs there. On that, this is a scale. tension is actually the force that exists